For problem 44, we're taking a look at finding two solutions that are between 0 and 360. So what that means, if we're looking at the unit circle, I'm basically looking at just one revolution of the unit circle, anywhere between 0 and 360 degrees. The reason why they state that is because the unit circle will keep repeating itself. So what you could do is you could keep saying that you'd have an answer in this, you'd have another answer here, you'd have another answer here, and so on. As you keep going around the unit circle, you could have an infinite number of answers. So looking at the first one, sine of theta equals 1/2. Sine is the vertical distance from the x-axis. So if I have a sine value of 1/2, that means that this distance here is 1/2. And then I would have another distance over here that also is 1/2. So making the triangles for this, I have two separate triangles. I have this one here, and I would have this one here. So what I need to figure out then is what is my angle measure here. So if this is a 1/2, and that is 1, this ends up being a 30, 60, 90, with my angle right in here being 30 degrees. That means that the other triangle over here is the exact same thing. That's also 30 degrees. Knowing that information, I can then figure out what sine of theta is going to be. So my theta value is going to be either 30 degrees, or that one would be 150 degrees. So theta equals 30 or 150. Those are my two solutions for that one. So when we take a look at problem B, I'm now looking at tangent. Tangent is the relationship of the sine divided by the cosine. And that is square root of 3. So when I look at a triangle in my unit circle, that means that my sine, that side, divided by my cosine, that side, is going to be the square root of 3. So square root of 3 over 2 for that side, and 1/2 for this side. If I look at that, when I take the square root of 3 over 2 divided by 1/2, that is the same thing as square root of 3 over 2 multiplied by the reciprocal of the divisor. So times 2 over 1. The 2 is reduced down to 1, and I'm left with the square root of 3. So the triangle that makes these right here work out is going to be, again, a 30, 60, 90 triangle. However, the angle in question, this one right here, is now my 60 degrees. The other triangle, because again I'm finding two solutions, the other triangle that's going to work with this is going to be the one in quadrant 3, where this is now a negative square root of 3 over 2, and this is a negative 1/2. The reason why this makes a positive square root of 3 is because I have two negatives, and when I divide those, they will become a positive. So my answer for problem B is going to be a 60-degree angle, and this one is going to be a 240-degree angle. So 60 degrees and 240 degrees. Problem C, cosine is square root of 3 over 2. Cosine is my horizontal distance, and it is positive, so it has to be this way. If that distance right there is the square root of 3 over 2, that means I can have a triangle here. We do that in a different color. I can also have a triangle here. Since the cosine is square root of 3 over 2, that means that the other side length here is going to be my 1/2. Also down here would be my negative 1/2. And those triangles are going to go with this angle measure being 30 degrees. That means that this one here is also 30 degrees. And the answer for theta is then going to be 30. And this one here is 330. The very last problem then, we're taking a look at sine again. So sine is our vertical distance. And this time it is a negative square root of 2 over 2. So if it's negative, that means we're going down. We're going to have two options here. Making my triangle then out of that. If this is a negative square root of 2 over 2, and this side over here is also a negative square root of 2 over 2, that means my triangle that I'm making here and the green one are going to be 45, 45, 90s. So my angle here and my angle here are both 45 degrees. That means then my angle all the way around to there is going to be 225 degrees. And the angle all the way around to there is going to be 315 degrees.